Oops. All right. Hello, everybody. Welcome. This is the first time we're doing Tech Talk on, I don't know, everywhere. We got Facebook, LinkedIn, Twitch, and YouTube. They say Facebook too. Let's see. And I'm Joe Carlson. I'm a developer advocate here at SingleStore, and I'm joined by Carl. Carl, I don't even know how do you pronounce your last name?
It's Carl Sever.
Sever, thank you. And Alexander Galejo?
So it depends, I think, on what like school of Spanish you went to school. Technically, it's called Gallego, but people say Gallego or Gallego is fine. I also go by Alex. I feel like Alexander is only when my mom gets angry and she's like, she pronounced my full name, and I was just like, oh, I did something bad. Anyway, it's great to be here.
Well, I'll be sure to call you Alexander when I scold you later on. If you mess up on the live stream, start swearing too much, I'll call you Alexander. No, I want you guys to introduce yourselves too and talk about like what you do, where you work, and then yeah, I guess let's just start there. So, Carl, what's your position? Where do you work?
Oh, I work at SingleStore, surprisingly. Been
Shocking.
here for actually 8.5 years, so it's been some time, been right since the beginning. I'm a director of engineering now, and I work with a new team that we have on the company called the Launchpad team. We're responsible for basically figuring out where the data industry is going in the next couple of years, and we're going to try to get there before anyone else does. So yeah, that's basically me.
That's awesome. All right, Alex, you're up.
Yeah, so nice to be here. Thanks, Joe and Carl, for having me. I am the founder and CEO of Redpanda. I guess by training, I've been a developer. I actually wrote the kernel bypass storage engine of Redpanda. And so I've been writing C++ for a really long time and have been doing streaming for, man, about 13 years now or so. So just streaming, I feel like this space is still unsolved, and I'm working on it. It's the second project I worked on. Built on computational models before with a company we sold to Akamai, but now we're focused on the storage. Yeah, excited to be here. So happy to answer any questions, as you know, literally as low level as like how long does it take a single page with a DMA write on an XFS file system, all the way up as to like why Redpanda and why do we made a source available.
No, I love that. I think I totally agree with you. I feel like the space for like distributed engineering is like kind of wide open. And personally, for me, I feel like the winners of that are going to be the ones that can make that easier than anyone else. You know what I mean? I mean, developers are smart,
yeah,
but like we got to make it easier than competitors.
Totally. There's like the way I say it to some of my friends that ask, I feel that if you draw like a complexity curve, I feel that most distributed systems were for like experts by experts.
Mm-hmm.
And it's kind of a shame, because then what happens is non-experts end up just hodgepodging things together with like a cron job and a Python script and maybe like Redis, which is fine because it gets their stuff done. But you miss sort of all the safety and guarantees and a bunch of goodies that you get for free if you were to make the tech easier to use. So I agree with you. I think making technology more accessible is really where the industry has to go.
Oh, I love that.
Yeah, I agree with that for sure.
So today we're going to be going through a demo that Carl built that utilizes SingleStore and Redpanda to make like a massively scalable parcel. What's the word? Like tracking application?
Yeah, I call it like logistics, like global package logistics.
Logistics. Yeah, that's a much better word. But before we do that, I want to like get to know you two better. And maybe Carl, could you start and just tell me like what got you into tech back in the day?
Well, that's a good question. I think my earliest memory of tech related stuff is my mom sending me to like a web like programming summer camp. I don't even know how old I was, maybe like 10 or 11 or something like that. And it was just very silly. Like, you just made some like HTML page and it was like very flashy at the time. This was like prior to JavaScript being as powerful as it is. So it was much more about, like back in the day of blink tags and GIFs. Learning all that stuff, and that just like got me hooked. And ever since then, I've just been wanting to build bigger and bigger things.
I love that. Do you remember what kind of computers you were developing on?
It was all Windows computers back then. I got really into Linux in like late middle school, high school, and then I've been sort of a Linux fanboy since then. And somehow
what was your first distribution?
Probably Ubuntu. maybe Debian. I don't know. It was probably Ubuntu or Debian at the beginning.
That checks out. None of the super stripped down.
Yeah, but then I nerded out and I got into NixOS. I don't know if you're familiar with that. For anyone on the call who's not familiar, NixOS is like one of the most extreme Linux distributions. You basically build up an entire like Linux distribution based on immutable packages and like a graph of dependencies. It's pretty hardcore, but the result is that you can literally throw away your laptop and get a new laptop and press a button and you get back to the precise same computer you had before, which is pretty cool.
That's amazing.
It's also extremely challenging to maintain, and also like to install Emacs, because I was like, when I started with Gentoo, sadly, and it was like so it meant that I didn't have a graphics card for like 11 months while I was trying to like Google on a different computer how to get graphics turned on. But it meant that downloading like Emacs just to edit a file, it's like an overnight thing, right? Like you just started at like 10 p.m. and then you wake up the next day and it's probably GCC 4 still running in the background with like, so yeah, I'm not sure. I think I'm pretty happy right now with the way the Linux distributions are. Like you download binary packages, it takes 5 seconds and you're up and running. Over a decade ago, it was just super slow and painful. So that's cool.
Oh yeah, no, totally. It's like way more accessible trying to get into it than it was. Yeah,
and modern Linux is fantastic. Like I've been running Linux as my main OS for years, and you know I've felt the pain of like the Linux a long time ago, and nowadays it's just so nice. Like the window managers work great, apps pretty much work. I even got like Steam games working on my Linux machine now. Like you know what's left.
No, totally.
I think Wi-Fi cards really only started working like 5 years ago. Let's be real. Like the last years you had to run that stupid cable across your living room, just like to your computer. It's just like I can't figure out how to get my Wi-Fi to work.
You know, it's a Linux machine, be the Ethernet cable. Like that's
at least to get it up and running initially.
I see someone in the chat is a fan of Gentoo.
Yeah, exactly.
What about you, Alex? When did you start programming?
Actually, pretty late in comparison with most of my peers. So I grew up in Colombia and I migrated to the States when I was like 15 or so.
Yeah.
And then I got this. My dad had this old compact Presario, and like the living room, and that was it's basically kind of like when I first started hacking with things and. I think like a lot of people when you're in like 9th grade, you're just Kazan and pirating music, or not pirating, just sharing music.
Sharing music.
Yeah, exactly. Totally. And then quickly like you start to write scripts to automate some of your music download and making sure that you're getting things and trading stuff. And that's really how I got into it. And then in college I was undecided. And then I did really well in my C++ class, which I'm still writing today, like 14 years later or 17 years later. And that was it. And then my advisor was like, hey, you're in the honors program. You should probably decide what you want to do. And I asked her, well, who do you advise? And she said, I advise the computer science major. I was like, okay, let's do that. And that was basically it. So it wasn't, it was pretty late stage, I think, in comparison with a bunch of other people.
Oh, totally. I feel the same way. Definitely got in later in life too. All right, let's see here. It's so good to meet all you guys and like chat and learn a little bit more about you. Should we jump into this this application? And see, Carl, I'm wondering, can you like tee us up? Like, what did you build? Why? What does it do? And then we can let's do a little demo.
So I remember back, I don't even know when this was, like maybe June or something like that. Whenever I was working on this, I pinged Alex. So first of all, going back a while, I don't know, remember, Alex, like when do you think I first started talking to you guys about Redpanda? It was like a year ago, something like that. It was like when you guys were still in pretty early stage.
You know what? It was probably when we just had announced the open source release. And you're like, hey, this is pretty cool. We should do something. Must have been like late 2020. So yeah.
Something like that. So yeah, so I remember, finding this Redpanda thing, and the first thing I did, I think, like after we chatted, was just figuring out like, does this work? And it worked. And I was like, oh, that's great. Like SingleStore Redpanda just works together. I don't have to like do anything. That's awesome. So then I was in the back of my mind, I was always like, I have to build something real with it. Like I can't just be like some, you know, basic like throw data in Redpanda, load it into SingleStore. Like it has to be something more interesting than that, to show off the fact that like you can run a workload for a while and do something very interesting. So that was my goal, and I sort of had this in the back of my head for a long time. And then I reached out to Alex like a month or maybe 2 months or whatever, a couple months ago, and I was like, okay, I'm gonna build something. And like at the time, I had some pretty lofty goals. I wanted to go basically build. My original goal was basically just like building UPS, like the entire backend of UPS, and I think I had like pretty lofty goals, but I reduced those goals down to just focusing on package logistics. So like just the single problem of like you have packages in a lot of different places around the world that need to get to other places. You need to figure out how to route them to those places. You need to make sure that you track those packages. So we want to be able to power the fundamental sort of goal, which is like tracking where did these packages go over some period of time. And I wanted to be able to do that using SingleStore. And then I needed a way, like a sort of high performance buffer that could take in a very large volume of package streams and then sort of hold that while SingleStore loads and organizes that data into tables. So it was like the perfect, I think, combination of Redpanda and SingleStore. So I put that together, and yeah, that's where we got. So I built something.
You know, it was really fun actually when you first reached out, because like one of the experiences we wanted to deliver with Redpanda was that it just works. Actually, Steve, who joined us in the chat, Steve is also running Redpanda in prod. I recognize his name. Anyways, and so that kind of experience of, hey, this thing just works was great, when just to get people like you, right, like super technical folks, in addition to just, you know, the application developers just trying to get things running. They often don't push Redpanda to the limits that you guys did, and so it's fun to see you doing it and having the same answers, like, yeah, it just worked. There was really no hand holding, and so it's a lot of fun to see you succeed.
Yeah, no, it's been a really good experience. So since then, I've just started recommending Redpanda to absolutely everyone with a streaming problem. So yeah, it's a good.
Awesome.
But maybe we can talk. I do want to talk a little about the actual problem space. I don't know if you can share my screen, Joe.
Yep, I'm on it. There we go.
So to get started, I have this janky little images. By the way, these images, a lot of people ask like, how do I make all my images? And the answer is a service called ExcaliDraw. And anyone who needs to make like very quick little diagrams and stuff like that, I really, really recommend it. I've just switched to using them for absolutely everything. So anyways, so one thing I was doing when I was like researching this project is I wanted to actually make a realistic data simulator. So I didn't want to make something that was like a, you know, just focused on moving data. I wanted to actually have sort of semi-realistic, interesting data. And the reason is because I want, when you go and talk to people in various industries, it's a lot easier to talk to them when you have really spent the time to understand their problem space, like their particular industry. So in this case, like I wanted to understand logistics, I wanted to understand global package logistics. And so I spent actually quite a lot of time understanding how the world's leading and best package logistics companies work. You probably can imagine like a lot of their names, like Amazon Prime, UPS, you know, FedEx. These are all companies that have been doing this for a long time. And there's actually quite a lot of papers that you can go read, an academic analysis of problems in this space. And it's a huge problem. Every single computer science theoretical issue, like, you know, like routing, for example, like traveling salesman problem, these problems all exist in global package logistics. Packing problems, like how do you figure out the number of packages to put in a plane? It's actually a really hard
problems. Yeah.
Yeah, exactly. So all these problems exist. It's a really cool problem space. So I had a lot of fun just learning. So just really quick, like this is really the main sort of flow chart that I wanted to focus on in my particular simulator, right? So effectively, if we've all delivered packages at some point, or like, you know, sent and received packages. So we sort of know, you know, packages get registered in the system, they get sort of dropped off, they eventually get arrived to some type of distribution center, and then they go through sort of a process where they are arrived, processed, departed, and transport it in a loop until they arrive to the final destination. Many packages go through multiple steps. Like if you've ever delivered something internationally, you'll know that like if you go look at the tracking log, you'll see like it left from San Francisco, it was delivered to Chicago, and then it was distributed over to like Toronto and then to Vancouver or something like that. And you're like, that's silly. Why didn't it just go straight up? And the answer is basically they need to be able to put packages in economic sort of systems. Like it needs to work with the economics of where they're moving packages, at what frequency, in what volume. And so there's a lot of really interesting problem spaces there in global package routing. Anyways, so long story short, this is sort of what I was focusing on with my simulator was trying to get this figured out. One thing I didn't do, and this is very interesting, is I didn't worry about the last mile problem. So the last mile problem is like an entire problem space in global logistics. Once you get the package to like the city, getting it from like the distribution center in a city, which has super high throughput, high volume, to the individual package being dropped off at someone's door is called the last mile problem. And it is an insanely hard problem. And it involves, it's as hard as the entire international delivery, in my opinion. It's bizarre, just because you're dealing with sort of singleton objects and you need to route them in a city, and there's a lot more timing related things. You know, people want to be able to get their package as quickly as possible. Once it gets to the distribution center, it's really annoying if it sits in there for like a week. You're like, why don't you just drive it over to me? It's like actually a really hard problem. So
Carl, I'm shocked you weren't able to solve that in your free time.
Yeah,
Amazon's probably got thousands of engineers and logistics business folks trying to solve that. So anyway, that's okay that you didn't solve the last mile problem today. That's okay. We'll forgive you.
Yeah, so I skipped that. But anyway, so you know, what did we build? So what I built was I built this sort of simulator, and we'll talk a little about what that does. But essentially, it simulates packages being picked up, going through those steps, and then eventually dropped off. So at any one point, the simulator is sort of has like a number of live packages that are in flight. Once it drops them off, like once it's finished their delivery chain, then it gets rid of them. So it just tracks them as long as they're sort of alive. They're moving around. Then we take that data, we ingest it into Redpanda. So we have a Redpanda cluster. And right now, my cluster is just 2 nodes. Redpanda is extremely efficient, CPU-wise, memory-wise, and disk-wise. And so you don't need a lot of nodes to handle. In addition, I decided to use Apache Avro. Is it Apache project? I think it's an Apache project. It is, right, Alex?
Yeah, I think so. Yeah, it's I think it's an Apache project, but it has basically libraries in every programming language. It's just kind of like protobuf and so on.
So Avro has a lot of really cool advantages that I'll actually show in the code if people are interested. But one thing that I do want to highlight is that I chose to, when I built this, I chose to basically have just the Avro schemas be sort of part of my application. If I was going to build this today, I would actually be using a new feature that Redpanda has, which is the Avro schema registry. Alex, do you want to just take a second to like explain what that is?
Totally. Yeah. So what I guess a big part of this when I started this, it really came from like my personal need. I was like, why is the streaming so hard? It honestly felt like distributed system whack-a-mole, where just to get a hello world, you have to have, it's just like just like teaching Zookeeper to behave well, and then you teach Kafka, and then you teach schema registry, and it's just like, why is it so hard to do basic things? And the problem is space is hard. And so what I wanted to do is like, well, can I make it easy, right? Like why is this only for experts? It doesn't make any sense. It's not like the JavaScript developer who's trying to prototype something and doesn't have the same problems. Of course they do, but I think just bridging the gap between the expert community and sort of the mid-career developer was a big part of what I wanted to do. And so with Redpanda, the thesis was, can we give people a single binary where the deployment model is you basically SCP it on 3 computers and then off you go? And so the story wasn't really complete just with being Kafka compatible. It had to be an ecosystem. And so we built an HTTP proxy if you want to translate between like Kafka binary protocol, which was really designed for like intra data center controls and network and conditions to like internal level. That was the first one. The second one that was a big one was the schema registry. And so the idea is that when you first start doing streaming, you're just trying to get something up and running. So you just shove some bytes and you're just like, yeah, I'll figure out how to read them later. At some point it comes back and hopefully it doesn't bite you if you use a flexible format, but a lot of times it does. And so what happens is people want to now start to work with the schema and say like, hey, I'm not sending like garbage and elephants and buildings and people, I'm sending packages. And so like I want to verify that the things that I put in here are, this basically exactly this JSON looking thing, which is Avro, and it tells you like what the type is. For example, here it says package ID is of type string, and it has a logical type of UUID, etc. So you want to start to give semantical meaning to the data that's actually flowing through your network. And so just to conclude that thought, the schema registry is now integral, right? And so we're really excited. We actually just released it last week. So, hopefully whoever is listening in, definitely use that. It's comes as part of Redpanda. It's just another port. You don't have to do anything. We actually extend the protocol so that every node looks the same, and we use this transactional method in Redpanda. But so that's what it was. I think it finally completes the ecosystem, and it allows you to start easy. So untype and then naturally evolve it into something that is like production, right? Like that was the whole thesis. It's like, can we get a developer on her laptop on a coffee shop but use the same system? And I think this is actually integral into how Carl wrote the thing too, into a petabyte level, like, parser logistics. Why not? Why can't the system be the same? Why is this graduation into like this exorbitant complexity? And I think in part, it's probably just maturation of technologies and thought processes and systems. But we're here, and so yeah, I don't know, maybe that was a roundabout way of describing the schema registry, but that was the philosophical take on it.
That was exactly what I wanted to hear.
I want to pause here because Alex is saying like this is if you want to start learning how to set up message queues or Kafka, like this is a great place to start. And in fact, I would recommend if anyone's like listening to this today, like check out our code. I have that bit.ly link here below. But if you want to learn about Redpanda, Kafka, message queues, real-time databases, Go, this project is a great place to start.
And I guess there's two projects, just to be clear. I think the project you just linked, Joe, goes to the workshop, right?
Yes. Yeah, exactly. But definitely, I think we have a link here to the Redpanda code base too.
So yeah, we definitely want people to like go look at this code and everything and just explore. But no, a lot of like what Alex was just saying really is one of the reasons why I'm so excited about Redpanda and why it fits so well with like SingleStore's philosophy. SingleStore also believes that deployment complexity is too hard, right? So SingleStore is a distributed relational database that you can run by just running the SingleStore C++ binary on a bunch of machines, network them together. Guess what Redpanda is? Same thing. Like one thing that I loved about working on this project, and what I'll do here is I'll just go into my code really quick. So basically, for local development, I literally just run vectorize. This is probably not the right version, but anyways, I run vectorize just locally inside Docker, just a single thing. I run SingleStore somewhere in here, locally. We both of us distribute like a ready to go single Docker image sort of deployment in dev environment. The crazy part about this is you could take this app as is, and deploy it to Google, right? So where I'm running the demo, which I'm going to be showing, is running in Google, and it's exact same code, except now it's running on, something like 8, 9, 10, 11, 12 plus, 16 Google instances in a clustered environment. And the only change I made to the Redpanda configuration is I said like RPK tune production. That was it. That was like the entire difference between my local development environment and the Redpanda. And similarly for SingleStore, I literally just deployed SingleStore onto 8 nodes, and I didn't do anything because SingleStore just automatically figures out the partition counts based on the size of the cluster. And it's like, okay, cool. It works. It scales. And the cool part about this is that like, because of the development simplicity, I was able to do things that are really annoying to do in most production systems. So like, for example, when I was working on this, I was doing a lot of performance testing. I was like trying to understand how to hit the absolute sort of limits of the systems. And when I was doing that, I literally was just like doubling the size of the cluster. and it would just figure it out. You know, it would just redeploy, and now I had 2x the performance, and that was really quite fun to sort of do.
You know, I think that's actually a philosophical design perspective that I think is different here. One is, to me, it doesn't make sense to when like you download a project, and I think the RPK tune too, and I know SingleStore does it automatically as well, but which is like, okay, great, how do I run this in production? And then there's like this huge list of like step 1, and then you're like a step 44, and you're like, I definitely messed something up. There's definitely a command that I didn't copy correctly, and something isn't working, or the network is in tune and whatever. And so we codified it into this thing called RPK tune. And similarly, you guys do it a lot of automatic stuff too on SingleStore. But I think that's by design. The idea is like, we are the storage experts in our case for Redpanda, and that's all. Like, trust us, we'll do the right thing. We run this in production for people.
Yeah, so just to really like highlight how epic this is the entirety of the Redpanda deploy code, all of it. It's 35 lines of code. Wow. Like, you don't have this. Like, imagine the entirety of the deploy code for Kafka. You have Kafka cluster, you have a Zookeeper cluster, you have, I don't know, a gazillion other things. They all need to be connected together. You know, this is the entire networking configuration of Redpanda. It's 2 lines. And similarly for SingleStore, we have to do a little bit more because we have to go and build a schema and stuff like that. But it's also pretty simple, right? Set up the aggregators, set up the leaves, load the schema. That's it. Do some tuning, right? That's all we do. So, awesome. Development simplicity is huge, but it's also, to me, the philosophical thing that I care most about, which is really aligned with between your 2 projects, is like, I want to develop an app on my computer and know that I can basically just like deploy the same app to a cluster and know that it's going to scale up correctly, right? That's the thing that I care about the most. And I think that this is something we've achieved with both of our systems. So we have talked about a lot about sort of this layer of the stack. I want to sort of keep moving on through the architecture a little bit. Yeah. So Redpanda is sort of the bus system in this architecture, right? So we sort of foresee, like, obviously in production, like let's say this was Amazon Prime, we wouldn't have like a bunch of simulator processes, like simulating packages. We would literally have edge locations all around the world sending in actual transactions, right? So essentially we're leveraging the scale out aspect of Redpanda, that we can essentially just expose those endpoints directly to all of our edge locations worldwide. And as those packages get scanned and get registered and so on, those transactions are flowing directly into Redpanda. So it's our data collection bus, like our stream, right?
I'm imagining your Go simulation clusters like a fire hydrant, and then Redpanda is like the hose that we're streaming that data through.
That's exactly right. Yeah, that's a good way to think about it. So Redpanda acts as sort of our data collection ecosystem. And it's really nice because Redpanda, because the data is basically just like raw in this form, it's really easy to scale. We don't have to worry too much about like scaling out different tables and like the state of the system. It's more just, we can just make it go faster, or we can make it go slower by just increasing the size of the cluster. It's also very easy to shard this model because, for example, I could run a Redpanda cluster in a bunch of different regions. And essentially now I automatically have essentially like region local data collection buses, which increases my redundancy. And then I can now still consume from all of those individual buses sort of at my leisure into SingleStore. So by adding a bus to your architecture, you gain a lot of flexibility as to like how you end up growing your system as it gets more and more complicated, and also a lot faster. So once we have that data in Redpanda, it's important we need to get that data into SingleStore so we can query it. And so the important part here is, how do you get data from a Kafka environment into SingleStore as fast as possible, but also as correctly as possible? And so we use a SingleStore feature called SingleStore Pipeline. And SingleStore Pipelines is a native SQL sort of component. So within SingleStore, I can actually show off what that looks like. So we're going to look at some SQL, which is very easy to read, absolutely not dense. Okay, so this is SQL. SingleStore has this sort of SQL extension called pipeline. So as we can see, we're creating a pipeline packages, and we're saying we're like loading data from a Kafka stream, which is defined by this endpoint, and then the schema format in the stream is Avro with like a particular schema. One thing to note is going back to the schema registry. This whole blob would be removable if you actually were using schema registries, which would be really convenient for not having to have duplicated schemas. But anyways, the point is that we're essentially defining this pipeline, and this pipeline is pulling data in by using essentially batches. So let me see if I can just do this live. 1 second.
Famous last words, Carl.
Oh, no. Trust me, I love doing these things live. Drawing live is like my favorite. I wish I had like a real whiteboard, but
I know, that'd be great, yeah.
So basically, we could think of a Kafka stream. Some people probably know this, but I think it's very useful to just like do this a little bit. Okay, so we can think of like a Kafka stream as like having a bunch of objects in the stream. And one thing that's interesting about Kafka streams is that these objects have, like within a Kafka stream, it's partitioned. So we have n partitions. So we could think of these as like n different fire hoses. In this case, we have 3 fire hoses. And within the fire hose, we have essentially objects in the stream. Now, Kafka has this very convenient property that this object might be offset number 1, this one's going to be 2, this one's going to be 3, and so on. Now, one thing that's really convenient about having sequential offsets is that we can read ranges from the stream. And we know that if we read 2 ranges from the stream, from the same partition to the same range, we get back the same data. This is the most important aspect of our SingleStore pipelines technology, because what we do is SingleStore is going to go ahead and read all of these objects all at the same time from Kafka in one distributed transaction. So we're going to go to Redpanda, and we're going to say, give us offsets 1 through 4 of all of our partitions. That's a very that's not a detailed oriented explanation, but it should give you enough information to understand how it works. We go to Redpanda, give us offsets 1 through 4, basically on all 3 partitions, and then we get back these data as like one big batch. We process the data as a batch in SingleStore, and then we commit that data in the SingleStore database along with the fact that we read these offsets. So there's a really cool.
So this is called, by the way, in outside of SingleStore, just for everyone else on the call. This is called global cuts. So what it is you like imagine a cake, and then you take like a knife, and then you make a cut, and then you take that cake and you say you eat that whole part of the cake, and then you take another big cut, and then you eat that part of the cake. So this is a global cut. And there are actually a bunch of new systems that are using actually the exact same architecture. There's a paper last year called Scale Log for people that are interested in doing some research that takes global cuts of Kafka partitions. And so, Carl, I actually have a question here just for clarification for the audience. Is there like, what's the epoch? What's the tick of consuming all, that one large batch at a time? Is that triggered inside memSQL, or like what's the epoch for getting this global cut?
So in SingleStore, we manage, I guess, like the epoch or how often we go to Redpanda based on the current volume of the stream. So very similar to how Redpanda uses control loops to do a lot of internal tuning of things. We essentially have a control loop that is trying to balance the batch size dynamically against the rate in which the stream is growing. And then there are a bunch of tunables, of course, that like help sophisticated administrator if they want to like tune things based on their own understanding of the system. But in general, like I'm not tuning anything. Like this system will sort of dynamically increase the batch size to keep up with the stream.
That's pretty cool. Sorry, anyways, go ahead. I just wanted to make an analogy to like a bunch of literature, which is called global cuts for people that are on the stream listening.
Love that.
Go read it. There you go. Very important.
Yeah, exactly. Also, you're so good at these things. I can't believe this is live for anyone. I'm like blown at how fast you are doing these drawings, because I'm so slow. So I'm impressed.
I feel like I live in Excalidraw. Like this is my, I like Excalidraw is my favorite tool ever. I pay for it on my own bill because I use it for so much. Like this is just, yeah, it's a yeah. Well, anyway, thank you. I really enjoy playing with this tool. But yeah, okay. So global cuts is great. I didn't know about this term, but it's basically exactly right. The whole point of this is that we achieve exactly once consistency, because if we failed to, for example, process this data, we will also fail in the same transaction to commit the fact that we read that data. And so that means that because Redpanda will allow us to reread the same set of offsets, we can always just throw away all of our work and then reread at a later time at our leisure. So if you imagine that like during the processing of one massive batch, SingleStore had some type of failure event that required us to reread, or there was a network failure or any number of problems, we can very easily just ignore the fact that that happened and we can reread later. We guarantees that if there is a object in Redpanda, we're guaranteed to load that object precisely one time. And you can always measure how exactly, like how far behind we are and so on. So you know exactly where SingleStore is relative to the overall stream. And this makes working with streams extremely easy. Like a lot of stream processing is like at least once or at most once processing. And when you're starting to work with that, you have a lot of similar problems you get with, for example, like eventual consistency databases. Like it can be very difficult to reason about your code and your architecture when you have to deal with those other consistency models from streams. I guess, Alex, you're like the absolute pro in this. Is there any other things like to point out about those types of models?
No, I think you guys, this is such a rat hole that I will not, I don't, but I guess one thing to highlight that you, just for people in the audience, like immutability is why streams are useful, actually. And so like the reason why Redpanda is useful in combination with SingleStore is when you write data to Redpanda, we actually durably write it to disk. And so if Redpanda crashes, and the transaction failed because it couldn't commit, it's okay because it simply retry again, and when the computers come back up, it'll read it from disk. And so you get two properties. One is we use the safe protocol, which is RAF, to make sure that you have enough replicas in the cluster. We use a quorum write. Those are technical details, but the application level, so if you're a developer and you're trying to understand streaming, there's really one property that will drive the majority of your decisions. And that property is immutability of your streams. It means once you put something into Redpanda, you cannot mutate it. It's like by design in the data model, you can't touch it. Because you can't touch it, you can build systems of records, right? Like, SingleStore, we can always rehydrate the entire log, right? You can rehydrate a petabyte of data and like give you the correct snapshot. So you can give you point queries and aggregates and point lookups. So two different systems, and one system, Redpanda is designed for like that kind of, very low level system of record almost, and give you immutability. And so, yeah, so that's only the one thing for folks writing applications to keep in mind with the streaming.
Cool. So yeah, I think that mostly explains the technical architecture. We essentially have a simulation. We have Redpanda, which allows us to sort of scale out and scale up depending on how we want to do things. And we have SingleStore. Everything's monitored by Prometheus, which is a great open source monitoring solution and essentially visualized in Grafana. So yeah, pretty much what's happening. Here's the live thing running. So we're currently delivering about 150,000 packages per second. Which equates to approximately 4.7 trillion packages delivered per year, which is about 45 times the global package volume in 2019. So should be fast enough for anyone. It's just a nice way to sort of put things into frame, is like how big of a volume we're doing in this relative demo.
No, I love that. What is SingleStore doing with the data once it's in the database?
Yeah, so great question. So we can go look at sort of the schemas. So there are 3 tables in this, or I guess 4 tables that really matter. So the first thing that you have to think about is how the core in any like domain of data. It's often true that there's like something that is unique. And so in this environment, the thing that is unique is the packages themselves, right? So a package exists, and a package is very much a unique thing. And so we have a packages table which stores one row essentially per package. And this is sort of our main metadata thing. So it tells us all of the metrics on this row are things we know at the time when the package was registered. Yeah.
Yeah. Okay. Yeah.
And so that's the first table. The second table is like a locations table. So it's important that, imagine for like Amazon Prime, they need to know all of their distribution centers. So the different distribution centers are things like, a distribution center in a city, or potentially like a massive like warehouse that they can use as like a hub somewhere. So we have a table that helps us do lookups on where those distribution centers are. We're using SingleStore's geospatial support extensively in this project. So we actually are using geography points, which actually understands like how the world works and how projections work and maps work to be able to do intelligent like distance calculations and index lookups. We have a package transitions table. So this is sort of the other object in the system, is like every single time a package is either scanned, departs a location, like it goes through some type of transition, we need to keep track of that happening. And the package transition table is fundamentally how we do something like a package tracking like website, right? Like when you go and say like, where's my package right now? Basically, they're running a query over this package transition table.
Yeah, it's in the city, then the city, then the center. Yeah.
Yeah,
gotcha.
exactly. So like, I mean, just for fun. So here's like the live data set, right? So if I wanted to like where package ID equals that, so this is like the package transition for this particular package. So like in 14 milliseconds or something like that, SingleStore is telling us exactly where these things are. I could join this this output against the locations table to know exactly like where these packages are, basically.
Wow. Let's see, we got a question in from someone in chat. How big is a SingleStore cluster to handle the load that's coming in from?
The current cluster is eight SingleStore leaf nodes. That's partially to handle. So if we like look at the actual performance of this system, so SingleStore during like processing the batches, it's basically spiking up to like 60–80% CPU, because it needs to do a lot of data transformations to go from like the raw transition stream to basically go and update and insert all those individual tables. So it's doing a lot of work there. And the Redpanda cluster is 2 nodes, which is, kudos to Redpanda for being so fast and scalable. And then the simulator cluster is another 4 nodes. So there's 4 simulation nodes that are pushing data. We can sort of see what some of these things look like. So like a simulator node.
And the CPU spikes, I think, because of compression of batches, probably. Carl, are you using compression as part of the simulators? Yeah. So that's probably where some of the CPU load is. So if people are trying to tune this for low latency, like when you're basically SingleStore can give you super low latency access, and same thing with Redpanda. So you can trick some parameters, and CPU utilization is obviously a big one. So play around with both batch sizes and compression types and ratios, so that it's all a trade-off. There's no free lunch, and so you're just moving the bottleneck around. Like if you want low latency, then you're moving the bottleneck to the network, and so on.
Alex, while I got you here, we have another question from Jack Ellis too. I don't think I can fit the whole thing on here, but if you go over to chat, you can read the whole question. It looks like he's asking about how Redpanda does with FIFO, first in, first out, and what kind of throughput limits they have with Redpanda.
Yeah, so we've measured at almost a gigabyte per second per partition. And so the way I like to give it, so the way we tune Redpanda for production for everyone in the room is we don't tell you to compare Redpanda with Kafka, with anything. We tell you just like take just measure the throughput of the disk, right? Like saturate the disk, and if Redpanda isn't saturating your disk, then it's our problem. That's a bug for us. And so it's actually very freeing, because on the network, like do iPerf, and on the disk side, there's Jens Aksobi's tool. The name escaped my name. It's FIO, right? So it's the disk FIO. And so when you run FIO on disk, it'll give you both latency, queue depth, the number of queues. So like, that is technically the saturation point. Partitions are really just a mental model so that we can comply with the Kafka API. So the general guidance here is if you're running on an NVMe SSD device, you should expect probably a little less than a gigabyte, just because there's a little bit of overhead. As soon as you have like 2 partitions or more, then you should be able to saturate the entire hardware. So anyways, Jack Ellis, that's the detailed answer.
Awesome. Thanks, Alex.
And I know Jack very well. He's an awesome developer, and he helps run Fathom Analytics, which it's just a fantastic service. And I think that one thing that Jack also really cares about is cloud. And I guess SingleStore has like a managed service, so we have like a fully managed thing, which is what Jack is using for Fathom. But I guess Alex, do you have any notes on the sort of equivalent for Redpanda?
Yeah, we have right now a private beta. We actually hold public Fortune 1000 companies inside our cloud. We've been, fortunate and super lucky, and we have more demand that we can keep up with. So definitely happy to extend the cloud to everyone in the call. Just reach us out to that. Also hit me up on Twitter if you don't want to send a form. We'll have a chat, and then we can hook you up with the cloud. But it's it's just like probably I think you guys have a fancier UI, but you get just a cloud native thing, and it runs on Google and Amazon. So we currently don't run on Azure yet. That's just what we have.
I know the feeling of wanting another cloud provider, but having to, it's surprisingly hard. It's like a lot of interesting things.
Do you know what's hard is disk kills you. Like there's so many gotchas with this. Like with GCP, we actually had to put in a kernel specific tuner for this, because GCP, for like 90% of their customers at the firmware level, they actually lie when you're saving data to disk. And so of course, because we use kernel bypass, we don't get any of those benefits. So we have to like GCP stop lying to the hardware, just like let the hardware be the hardware. And so that's the part that is time consuming. Like a developer runs it on a computer. It's like, hey, like it's fantastic. And you're like, oh, this is like, it's really shit latency on GCP. And just like, let's fix that. That's the part that it's like a long tail to integrate in cloud. So right now it's just GCP and AWS.
Makes sense.
Nope, love that.
Is there any other questions in the chat that we didn't handle yet?
I don't think so. Looks good. A lot of people are just handling Jack's questions about Redpanda. I'm curious, what did you say it was like average daily throughput for like packages in the real world, and what did you say your thing is capable of doing?
I don't remember off the top of my head. I can't remember the daily throughput, but the yearly throughput was I didn't keep those numbers. But hey, we have conveniently we have the internet. I guess
I'm like, is this accurately representing what is? Oh yeah, that's right. It's in this article. That's right. That's where I read about this.
Yeah, so we were like doing some research, and we found that in 2019, there's actually like an index that like reports on this every year, so it's really cool. But in 2019, which was like the last report they managed to get out, is 103 billion packages in the year, which equates to about 282 million packages delivered per day. So yeah, it's honestly not that high of a volume. It's basically 3,000 packages per second, right? Like both Redpanda and SingleStore can handle this entire workload on a single machine, and not even a powerful machine. Like you can run this entire workload on like your laptop, and still have like a lot of CPU and disk to spare. So it's not a huge workload by any means. But what's really interesting about workload is that it is a global workload. And so by having SingleStore and Redpanda with our scalability, we can do things that are very interesting. So like, because the volume is actually pretty low, we can store this data, for example, in like many different places around the world for like edge delivery. We can do really fast like replication worldwide. We can leverage, we can leverage our performance to be able to do queries that would be actually very hard. So even though you have 103 billion packages, not a lot of data, like doing queries on 103 billion rows with like all of the extra rows and all of the things involved can actually be pretty expensive. The way that a lot of the global package logistics systems deal with this problem is they essentially shard the problem. So in all of their edge locations, like all their distribution centers and hubs, they actually run essentially a full database environment and like a full version of essentially their application. And so each of those different environments are running and dealing with the packages, the transitions that are happening like locally in that center. And then they essentially have to do a much more difficult problem of, okay, now we have all the data, but how do we actually answer queries like, where did my package go in the last like 24 hours? And now you have to potentially go and talk to like a bunch of different places or replicate that data up to the cloud or something like that.
Yeah, I would add one more thing there, Carl, too, which is like, it's not just packages. What happens with data intensive applications is like, okay, you start with like 3,000 requests per second, but then what happens after is someone in like let's say me, the CEO, just like, well, how much money are we actually making? Like we have to run a business, right? And so you start to run these reports. Not too long of a distance for what we're seeing in some of our customers is you actually jump 10 to 20x the raw inches volume, right? And so it is pretty normal for companies to have 10, 20, 15 pipelines. When I was at Akamai, I think we had something like 107 on this particular streaming cluster, right? And so it's just like 107x any input of the raw data. So that's what data intensive apps do. It's like the more data you have, the more interesting it gets, the more problems you want to do. You probably throw in some TensorFlow at some point, and then start rendering dashboard. It's just kind of like the limit.
Yeah,
that's amazing. We have about 10 minutes left in the stream here. If anyone has any questions, be sure to get those in before we wrap up here. But Carl, I would love if you could talk about like what some of the hardest issues or bugs you encountered while you were working on this app.
Yeah, I mean, I have some fun ones. So I think a lot of people in the chat are developers, and you might enjoy sort of like thinking about these problems. But so geospatial math and geospatial concepts are a little bit tricky. I don't know if anyone's worked with geospatial extensively, but now I have, and it turns out it's like a little bit weird. So there's a couple of things that are very interesting. The first thing is like understanding projections. So I guess if you can just share my screen really quick.
Yeah. Oh yeah. There we go.
So I found this GIF, and I thought it was like a pretty useful representation of the difficulty of dealing with projections. But a good example of like, if we think about Google, right? So here's like the world map on Google. So you notice like how big Greenland is. This is not the size of Greenland in comparison to like Canada and the United States.
It's not? I lied to you, Carl?
Similarly, Antarctica is not this big. and you got to wonder like, well, why are these things scaled so much? And actually like they're scaled a lot. This is sort of an example of, this is the real size of Greenland, and this is the size that appears on like a map, right? And so effectively, when you take a sphere, which is the Earth, it's not actually spherical, but it's spherical-ish, and you map it to like a rectangular plane, you have to decide like how you map a coordinate on that sphere to that corresponding plane. And this is called map projections. And map projections, there's a gazillion map projections. The one that I guess probably most people are familiar with is Mercator, right? So Mercator is the one that Google leverages, right? This is why it has these weird things. But to think about it, it's like, well, how often on people's like daily lives does it actually matter that Greenland is skewed so much, right? Like how often are you getting the distance between like here and here, and it says it's like, 2 kilometers? You're like, wait, that doesn't look like 2 kilometers. It doesn't really matter, right? What really matters is that like when you maybe go between like Iowa and Illinois, it actually gives you like a reasonable, the scale near sort of where the major population centers is like much more accurate. And so that's essentially how Mercator's sort of solved it, is it's basically made the scale near the equator much more accurate compared to the scale at the poles. And this allows for like map operations that happen near the majority of human population centers to be very accurate. Whereas unfortunately, if you live in like northern Russia, it's going to look really weird, right, compared to like reality. So that's sort of something that's very interesting that I learned, and it was definitely a challenge, because if you imagine, for example, like what I have to do in the simulator is I have a package at like position A, and I need to figure out a route for it to get to position B. And I want to be sort of semi-realistic. So I'm not just going to send the packages directly from A to B. I'm going to try to send them like to a bunch of intermediate points on the way from between A and B. And in order to do this, you essentially need to do like a graph sort of like shortest path search, but it's like a little bit of a heuristic path search, because what you're trying to do is not necessarily do a shortest path. You're trying to, for example, route packages that are in small towns to hubs, which are like larger population centers, route them between those hubs to sort of simulate the fact that they have a much higher throughput, and then from those like final hubs to the like local town, right? So if you're going from like a small town in the US to like a small town in China, you know, you don't just go from small town to small town. They don't have international flights between those two locations. Like that's not a thing. So you have to go through like a couple of hubs on the way. So long story short, when you're doing that, like imagine that you're routing a package like between Japan, for example, and San Francisco. Oops. So Japan and San Francisco goes across this line, and this line represents basically the edge of like latitude, longitude coordinates. So if we think about latitude, longitude usually, and we think about them as like degrees, like from negative 180 degrees to 180 degrees. So the point between negative 180 and 180 is still that there's zero distance between those two locations, and that's what represented by this red line. If you try to route a package between here and here, you have to deal with the fact that your numbers start looking really weird, because the shortest path is actually going across that line, right? Which means that if you just do your math naively, you could end up with a number that is like very, very large, because it's like, oh, it's like you could potentially route a package instead of across this line, you could route a package around the entire world the other
Oh,
direction.
sure. Whoops.
That's a really interesting problem. So anyway, so I really enjoyed like learning about this type of math. I haven't had to deal with geospatial math like before, and I ended up writing basically a custom index in Go, which was like in the code. You can go and see it. So I wrote a custom index to be able to accelerate the simulator code. The index uses a quad tree, which allows us to very quickly look up any location on the map by like distance from a point. So for example, I could like say, what are like the closest locations to like this particular point? I use a hash table, which allows me to just quickly look up locations by ID, which allows me, there's a couple of reasons for that. I use a sorted index. So sorted index gets me the ability to select locations basically like weighted by their population. So that's like an interesting, nice way to solve that problem. And then you also need essentially a k-nearest neighbor index. So a k-nearest neighbor index can be represented in a lot of ways. The way I represented it is that each location points at the k-nearest other locations in different directions. And the reason we need different directions is because we actually aren't doing like a shortest path search through a graph. We're doing like a routing search that leverages, for example, the fact that a location might be like a point or a hub, like a small location center or a big location center. So there's a lot of detail there, but it was a lot of fun. There was definitely a lot of challenges.
Wow, I'm surprised you had to build that all by yourself too. Like it feels like a solved problem, right? But I know it's like tough too, right?
You think there's just very few reasons for this type of stuff to be like open source code.
I see. Let's see here. Alex, we have actually a question for you that just came in from Yaren. He's curious if he wants you to talk a little bit more about the disk tuning you did for Google Cloud Platform.
Yeah. Let me summarize my work because this is a deep rat hole. So let's see. Linux kernel gives you like a cache profile object for coherency. So if you have two threads, you can access this global object, and it has global semantics. We don't use the page cache. And so the problem that we were seeing is that syncing to disk took multiple seconds. And you're just like, I don't know what the hell this thing is doing. Like, it's like, I understand computed speeds. It shouldn't take multiple seconds to flush a page to disk. And what they were doing is they were trying to actually amortize, because internally inside GCP, the buffers to write to disk are way larger than our buffers. So internally, Redpanda has 16 kilobyte buffers. GCP has like multiple megabyte buffers that they flush to disk to allocate with the NVMe SSD sectors at the low level of the NVMe SSD controller, getting too low level. That was the technical bug. And so the tuning was like telling the kernel, I was like, don't touch it. But I mean, really don't touch it. And we worked really hard on it. And so we were able to whack-a-mole a tune, and it's on GitHub, so you can go check out the code and see exactly actually what happens. But that was the problem description.
Yeah, that
Sorry,
sounds.
I kind of like derailed this whole thing, but that does.
No. The people want to know, Alex. Okay, the people want to know. Yeah, go check out the code base if you want to go. Is it in the Redpanda GitHub?
Yes.
Cool. Yeah, if you want to check out the tuning, for sure, go check that out. Let's see here. I think we're about out of time. So I want to wrap this up here. Any closing thoughts or anything you guys want to plug or talk about before we wrap up here today?
I definitely want to plug the workshop. So the logistics sim is really cool because it's an example of like a real thing, right? But actually, it's much simpler to start with something more straightforward, and like especially if it's a tutorial. So I wrote a workshop which actually goes step by step from like almost scratch of the pieces you need to put in place to connect like SingleStore, Redpanda, and your app into like one nice little thing. And so I do recommend going through that workshop. It's linked there on the screen. And it should, by the end of it, you should at least have a good idea of, a way to connect everything together in a pretty high performance way that scales really well, assuming you use Go. If you don't use Go, I think you could still use a lot of the same concepts in the tutorial. You'll just have to change the code a little bit.
Yeah, it's really easy to set up. It's great. I definitely recommend checking that out too. What about you, Alex? Anything you want to touch on before we wrap up here today?
Just honestly, if you have questions, hit us up on Twitter. So like you can hit me up or Carl or something like that. We have Slack. That's basically have fun. This is a lot of fun to see Carl succeed here and see you guys be successful and put this demo. It's amazing. You guys did a great work, and Carl had to become an expert, which is rad. In like 2 weeks. So just throw any hard problem at Carl, he'll solve it. I like it. Yeah, that's all, guys. It's a pleasure being here.
No, I love it. I'm just going to end here. If you guys aren't following, we're going to be doing a lot more streams on these platforms in the future. So be sure you like and follow. That lets us know that you like it. Let us know what your thoughts are on it. We'd love to do more of these in the future. The more people we hear from, the more likes, the more shares, more views we get, the more likely we can do that and talk about the things that you want us to talk about. I'm also going to push you guys over to go check out the SingleStore developer page. If you want to check out projects, code, documentation, trainings, whatever about learning SingleStore, for sure go check that out. And if you have any questions about SingleStore, you get stuck on something, you need some help, the best way to get that solved is on the SingleStore community forums. That's at singlestore.com/forum, or you can use that bit.ly link linked here too. And lastly, be sure to check out SingleStore. We have a free tier, and it's the easiest way to get set up in the cloud. And I'm going to go ahead and push to. You should try Redpanda and Vectorize too. They also have a free tier you should check out.
Thank you, guys. It's a pleasure being here. Yeah. Bye, everyone.
Thanks,
Absolutely.
Everyone.
You guys have been so incredible. I've learned so much from you two today. This has been such an honor. Thank you so much.
Thanks for hosting, Joe.
All right. Yeah. Hang on the line, guys.